So guys, I will guide you through the code of how to implement a TCP server. So our implementation will be in compliance with this flowchart. So we will see that how we will implement a TCP server while being abide by this flowchart at the same time. So we will go through these 10 steps and we will see how to implement all these 10 steps while implementing a TCP server. So the first step, as you can see, is the initialize variables. So we have a program that implements the easiest TCP server that you can ever implement. So we have written a function setup TCP server communication. This function will take up the responsibility to implement all the 10 steps of the TCP server. So let's go through this function. So the first step is the initialization of variables. So as I said, that the first thing that the server does is to create a master socket file descriptor, and which is again all the file descriptors are nothing but these are integer values. So we have initialized the variable master socket file descriptor and we have initialized to 0, right? And rest of the variables we will discuss when we will be using these variables in our discussion. Then as soon as the server receives the client connection request, the server creates a communication file descriptor. So you can see in this diagram, as soon as the server receives the client connection request, the server calls the accept system call and creates the communication file descriptor, because the server needs to communicate with the client, and for that the server needs communication file descriptor. So for that we have taken a variable communication file descriptor and has initialized that to 0. Now fd underscore set is the file descriptor set, that is, the server has to maintain the pool of all connected clients, and for that the server maintains a set. In that set we maintain the file descriptors of all connected clients. So the data type of file descriptors, so the data type that is provided by the C API is fd underscore set, and read FDS is a variable name. Then struct sock addr in is the structure that we use to specify the server or the client address, that is any machine address. So this is all about initialization of variables. Now in the step 2 we create a master socket. So let's come to the step 2. Now as soon as the server is done with the initialization of variables, the server creates a master socket file descriptor. The master socket file descriptor is created using socket system call. So if you discuss the synopsis of the socket system call, the first argument of the socket system call is actually the address family. So in our case it will be AF underscore INET. Why AF underscore INET? Because we are dealing with IPv4. We are dealing with IPv4 networks or IPv4 network communication. If we were dealing with IPv6 network communication, then the address family that we will have to pass as the first argument in the socket system call would have been AF underscore INET6. That is this. But we need to pass only AF underscore INET most of the time. The second argument and the third argument together, combined together, they specify the type of sockets that you are creating. Since we are creating a TCP socket, for TCP socket the second argument has to be sock stream, and the third argument is the protocol identifier. Since we are creating a TCP server, therefore we will have to specify IP proto TCP. So we will discuss when we will be creating UDP based server, that is the server which communicates with the client using UDP sockets, that what type of parameters we will going to pass here. But in this case, since we are creating a TCP server, the second and third argument for TCP is socket stream and IP proto TCP. So this socket system call returns a positive integer value if it succeeds. Otherwise, it returns -1 if it fails for some reason. So in the step 3, in line number 45, we have already created a master socket file descriptor. Now the step 3 is the bind. Now what actually bind does? So to use a bind system call, first of all, we need to specify the server information in the server ADDR structure, that is this structure. And what is server information? Server information means a server is a process which is running on a machine. We need the credentials for that machine, that is what is the IP address of the machine and what is the port number on which the server process is listening on server machine. So again, server ADDR has 3 members that we should fill. Server ADDR.syn family is again, it is a constant for IPv4 socket programming, so it will be AF_INET. Server ADDR.syn port is actually the port number on which our server process is listening. So I have already explained the concept of port number. So port number is an integer value on which the server process or client process is actually communicating with each other. So in this case, the server port number is actually 2000. So it's a hash defined. So it's a constant. So basically we have created a server which is listening on port number 2000. And the third member that we will going to fill in server_ADDR structure is the server IP address, that is the IP address on which server process is listening. Now here we can pass the constant in ADDR_any. It is a predefined constant that is defined in a standard C header files. So in ADDR any means the IP address of any local interface of the server machine. That means if the server receives a packet with destination IP address is equal to IP address of any local interface of a server machine, the operating system will going to accept that packet and will hand over that packet to the server process. Right? It may be the scenario that you would want your server process to run on a particular IP address instead of IP address of any local interface. In that case, instead of in ADDR any, you should specify the integral value of that particular IP address on which your server process wants to run. For example, the loopback IP address of the server machine, say, is 192.168.56.101. So the integer equivalent of this IP address is this value. So it is this value that you should have specified instead of in ADDR_any. So had you specified this integral value instead of in ADDR_any, your server process would only accept the packet in which the destination IP address is equal to 192.168.56.101. Otherwise, you can straight away specify in ADDR_any value. It means that the client sending a packet to the server by specifying the destination IP address as IP address of any local interface of a server machine. Then ADDR length is again a constant value and it is size of struct sock ADDR. Now here I have explained that what does the bind system call do. So bind system call is actually, first of all, bind system call is used on the server side binding means we are telling, we means the server process. The server process is telling the operating system that any data that the operating system receive with destination IP address is equal to 192.56.101 in case if we have specified this value, and if the TCP port number in the packet is 2000, then server process is actually instructing the operating system that if you receive any packet with this IP address and 2000 port number, send that data or that packet to me, that is to the server process. So bind is actually a mechanism to tell the operating system by the application. In this case, the application is our server process, that is this program. So bind is a mechanism to tell the operating system what kind of data server process is interested to receive. Remember, server machine can run multiple server processes to process different data and service different clients. Note that bind is used on the server side and not on the client side. So if we were to discuss the synopsis of the bind system call, the first argument to the bind system call is the master socket file descriptor. The second argument of the bind system call is actually the server pointer to the server ADDR structure. And we have already filled the server information in this server ADDR structure, that is the IP address on which our server process is running, as well as the port number on which our server process is listening. And the third argument is a constant, which is size of this structure. So this bind system call will tell the operating system that this server process is interested in receiving the packet in which destination IP address is specified as this value and the port number is this value. So if in the packet received on the server machine, if the destination IP address and the TCP port number is in accordance with the value that we have filled in this structure, the operating system will going to hand over those packets to this server process. So this is the concept of bind system call. Then the fourth step is the listen system call. So listen system call, again going by the definition of system call are the set of APIs which is used by the application to convey some information to the operating system. So like we have used the system call as bind, as well as we have already used the system call socket. So you can see that the application is using the system call APIs to actually talk to the operating system. So using the listen system call, our server process is telling the operating system to maintain the queue of maximum length 5. It means that to a server process, it means that if we have a server process and at the same time the request comes from client C1, client C2, client C3 and so on, then the operating system will going to queue the request of these clients C1, C2, C3 and it will dispatch the request of these clients to the server process one by one. So we are actually instructing the operating system to maintain such queue with maximum length 5. If the server machine receives the client request for more than 5 clients, then the server machine will going to drop the extra requests. So this is the purpose of listen system call. Now going forward, the fifth point is the initialize and fill readFTS set. So initialize the readFTS set means So basically fd underscore set is the data type and readFDS is the variable. So in the initialization phase, we have already discussed that fd underscore set is the data type and readFDS is the variable. And this variable is used to store the set of file descriptors. File descriptors are nothing but these are integers. So basically readFDS is the set of integers. So fd underscore 0 is a standard macro that is provided to us by the C API. And fd underscore 0 actually removes all the file descriptors present in the readFDS set. So it has drained or emptied the entire readFDS set. In the next step, we will going to add the master socket file descriptor to the readFDS set. For that, the macro provided to us is the fd underscore set. So by this point of, so at this point, we have actually added the master socket file descriptor to the readFDS set. Now, sixth point is the select system call. So now the server is invoking the select system call. The synopsis of the select system call is that the first argument is the maximum file descriptor that is present in readFDS set. At this point of time, the only file descriptor that is present in the readFDS set is the master socket file descriptor, because we have added master socket file descriptor here. So the first argument of the select system call is master socket file descriptor plus 1. The specification of select system call says that the first argument of the select system call must be the maximum value of the file descriptor which is present in readFDS set plus 1. And of course, the second argument to the select system call is the readFDS set itself. For advanced usage of the select system call, the argument third, fourth, and fifth is also provided, which is out of the context of our discussion here. So you can pass the null values here. Their discussion is not worth to discuss here. So at this point of time, our server process is now blocked at this select system call. So remember, select system call is a blocking system call. So in this diagram, we are here. That is, we have initialized the master socket file descriptor. We have put the master socket file descriptor in a readFDS set. And now we have called the select system call. And now we are blocked. So blocked means the server is now waiting for new client connection request. So the line 94 will execute only when the server has actually received the new client connection request. That is, the server has unblocked. Right? Now, once the server is unblocked, we will have to check that whether it is the master socket file descriptor which is activated. Because in the readFDS set, there could be other file descriptor. However, in this example, we have taken only master socket file descriptor as the only file descriptor present in readFDS set. So in the next example, when we will be discussing the more complicated example of writing a TCP server, there you will understand that why it is necessary to check that which file descriptor is actually set. Because select system call will going to unblock whenever any file descriptor present in readFDS set is activated. So in our case, this condition will going to be true. Why? Because the only file descriptor present in readFDS set is the master socket file descriptor. That is, the select system call was monitoring only the master socket file descriptor, and therefore the master socket file descriptor will be activated. So we have print that new connection request has received, and the next thing that we're going to do is to accept the connection. So at this point of time, that is after the accept system call, the three-way handshake between the client and the server is completed. So we are here, that is master socket file descriptor activated? Yes. We're going to invoke the accept system call. So here we have invoked the accept system call. Again, remember the synopsis of the accept system call. The first argument to the accept system call is the master socket file descriptor. The second argument is the pointer to the structure client ADDR. So this is an empty structure, and when the accept system call is invoked, this structure will be filled with the client information. Now what is that client information? It is the client IP address and the client source port number. The server will use this information to reply back to the client. And to reply back to the client, the server needs to know the client IP address as well as the client process port number. And again, the third argument is the constant, which is the size of struct sock ADDR structure. So the accept system call returns the communication file descriptor, which is again an integer value, a positive integer value. If for some reason this value returned is less than 0, it means the accept system call has failed. So when we reach on line 111, at this point of time, the connection between the client and the server is fully established. On the server side, we are printing that which client has actually connected to server. So we are printing the client IP address as well as the client port number. So we have accepted the connection here, and the connection between the client and the server is fully established. Now we are entering into the while loop. Why we are entering into the while loop? Because the server usually are 24/7 up. So why we are entering into the while loop? Because the server are actually of the nature that they have to be up all the time. So server logic are usually implemented inside the infinite loop. Now at this point of time, the server has established the TCP connection with the client. Now we are taking a data buffer, and we are just draining any residual bits or residual data in this data buffer using memset. Now the server process has invoked the receive from system call. Receive from system call is used to receive the data from the operating system, provided that the operating system has received the data from the client. If the server process invokes the receive from system call and the client has not yet sent any data, the server will block here. So it's a blocking system call, and unless the data arrives on the communication file descriptor, the server process will stay blocked. So at this point of time, in line number 125, we have accomplished so far the following. The client C and the server S has established the bidirectional TCP connection. And after the server has accepted the connection and created communication file descriptor, the server has actually invoked receive from system call. So the server is actually on receive from. That is, the server is now waiting for the data from the client C. Till now, the client C has not yet sent any data to the server. So at this point of time, the server is blocked. Now, the synopsis of this receive from system call is that The first argument to the receive from system call is the communication file descriptor which the server S has created to communicate with the client C. So remember, the sending of the data or the receive of the data happens on the communication file descriptor. The second argument is the buffer which the server has to pass in order to receive the data or to read the data that has been received from the client. The third argument is the size of the buffer. The fourth argument you can just pass none. The fifth argument is actually the credentials of the client from which the server wants to receive the data. Remember that this client ADDR structure is already populated with the client C's IP address and port number in the accept system call. So this receive from system call will be blocked unless the server machine receives the data from client whose IP address and port number is specified in this structure. Now suppose we are here, that is the server is unblocked. When the server gets unblocked, the receive from system call returns the number of bytes that is received from the client C. So server received, so we are printing that the server has received these many bytes from client this, port number this. Now we have placed our own condition, that is our own criteria, that if the client C for some reason the server detects that the number of bytes received from the client is 0, the server just closes the connection with the client and go to step 5. So let's assume that the client has sent some valid data to the server S. So that valid data will be stored in the buffer that is provided by the server process in the receive from system call. So typecast that data into test struct structure, and we are calling that structure as client data. Now we are assuming here that the client will send a data to the server as two numbers, unsigned int A and unsigned int B. Right? So this is the test structure. So we have assumed here that the client is sending the data to the server in this format. Now here we are checking that has the client sent the data to the server where A and B values both set to 0. We have taken this as a criteria for the server to close the connection with the client. Otherwise it could be any other criteria to close the connection. Let us say that the value of A and B is not 0. The client simply adds the values of A and B and store the result. So what is the result structure? We can see that the result is nothing but it is simply the unsigned int value which will store the addition of A and B values. Now the server has to reply back to the client with the result. For that, the server invokes the send to system call. The send to system call is invoked on the communication file descriptor, like receive from system call. So the first argument to the send to system call is the communication file descriptor, because the server is now communicating with the client and all the data exchange with the client takes place on communication file descriptor. Then the second argument is the pointer to the result memory, pointer to the memory where results are stored, and the size of the result buffer. Then again the fourth argument could be null. The fifth argument is actually the information about the client to which the server is actually sending the data, that is client IP address and port number. We have already filled this information in client ADDR structure using accept system call. And the last argument is the constant value, that is size of struct sockAddr. So send to system call is not a blocking system call, and send to system call receives the number of bytes sent by the server. So here we are printing that the server has sent these many bytes in reply to a client. So this is the whole cycle of, this is the 10 steps that we have discussed in implementing the TCP server. So we have discussed all the steps, that a server has accepted the connection and the server has serviced the client with the reply. And we also discussed the criteria of closing the connection with the client. After the client has been serviced, the server goes to step 5, that is initialize and fill readFDS. So what is the step 5? That is the server goes back to the while loop, and again the server removes all the file descriptor from readFDS set and put back the master socket file descriptor in the readFDS set. And again the server blocks on the master socket file descriptor, that is the server blocks, that is the server waits for the new client connection request. So this is the cycle, or as you can say that this is the steps of implementing a TCP server. So you are encouraged to write a program on your own and implement all these steps of the TCP server. Now, there is one drawback in this example. The drawback is that if you implement these steps of implementing a TCP server, your server will have limitation that it can service only one client at a time. Because once the server accepts the connection from the client at this line, server goes in the infinite loop and server invokes the receive from system call. So in line number 125, after accepting the connection from the client, the server is actually blocked, and it will stay blocked unless the client sends some data to the server again. So you can see in line number 125, your server cannot service any other client because your server is in a block state. So we have taken this example to explain the steps because this is the simplest server that you can design. So this server has a limitation that it can service only one client at a time. In the next example, we will alleviate this drawback from the server and we will redesign the server such that the server can service many clients at the same time. So you are encouraged to write this example on your own and implement all the 10 steps of writing a TCP server, analyze the code, run the code, and understand the steps of writing a TCP server. From the interview perspective, it is very important question that you are often asked to explain the purpose of accept system call, the purpose of select system call, and straight away you can also be asked to describe the steps of implementing a TCP server. So all these 10 steps should be crystal clear to you. So next we will take another example of how to implement a TCP server which can handle multiple clients at the same time.